So now we've got a custom image folder class that replicates the functionality of the original image folder data loader class, or dataset class that is. Let's test it out. Let's see if it works on our own custom data. So we're going to create a transform here so that we can transform our images, raw JPEG images, into tensors, because that's the whole goal of importing data into PyTorch. So let's set up a train transforms compose. We're going to set it to equal to transforms.compose, and I'm going to pass in a list here that it's going to be transforms. We're going to resize it to 6464. Whatever the image size, we'll reduce it down to 6464. Then we're going to go transforms.random horizontal flip. We don't need to necessarily flip them, but we're going to do it anyway just to see if it works. And then let's put in here transforms.toTensor, because our images are getting opened as a pill image using image.open, but now we're using the toTransform from PyTorch or TorchVisions.transforms. So I'll just put this here from TorchVision.transforms. That way you know we're importing transforms there. And let's create one for the test data set as well, test transforms. We'll set this up. Oh, excuse me. I need to just go import transforms. And let's go transforms.compose. And we'll pass in another list. We're going to do the exact same as above. We'll set up resize, and we'll set the size equal to 6464. And then transforms, we're going to go .toTensor. We're going to skip the data augmentation for the test data, because typically you don't manipulate your test data in terms of data augmentation. You just convert it into a tensor rather than manipulate its orientation, shape, size, etc., etc. So let's run this. And now let's see how image folder custom class works. Test out image folder custom. Let's go, we'll set up the train data custom is equal to image folder custom, and then we'll set up the tag.dir, which is equal to the training directory, and then we'll pass in the transform, which is equal to the train transforms, which we just created above, train transforms. And then we're going to, I think that's all we need actually. We only had two parameters there. We're not going to use a target transform because our labels, we've got a helper function to transform our labels. So test data custom is going to be image folder custom, and I'm going to set up the tag.dir to be equal to the test directory, and the transform is going to be the test transforms from the cell above there. And what's Colab telling me there? Oh, I'm going to set that up. Did we spell something? Oh, we spelled it wrong. Train transforms. There we go. Beautiful. Now let's have a look at our train data and test data custom. See if it worked. What do we have? Oh, we have an image folder custom. Well, it doesn't give us as much rich information as just checking it out as it does for the train data, but that's okay. We can still inspect these. So this is our original one made with image folder, and we've got now train data custom and test data custom. Let's see if we can get some information from these. So let's check the original length of the train data and see if we can use the len method on our train data custom. Did that work? Wonderful. Now how about we do it for the original test data made with image folder and our custom version made with test data or image folder custom. Beautiful. That's exactly what we want. And now let's have a look at the train data custom. Let's see if the classes attribute comes up. .classes, and we'll just leave that there. We'll do the class.idx. Yes, it is. So this attribute here is, I wonder if we get information from Google Colab. Loading. What do we get? Oh, classes to IDX, classes, load image, paths, transform. So if we go back up here, all these attributes are from here. Paths, transform, classes, class to IDX, as well as load image. So this is all coming from the code that we wrote, our custom dataset class. So let's keep pushing forward. let's have a look at the class to IDX. Do we get the same as what we wanted before? Yes, we do. Beautiful. A dictionary containing our string names and their integer associations. So let's now check for equality. We can do this by going check for equality between original image folder dataset and image folder custom dataset. Now we've kind of already done that here, but let's just try it out. Let's go print. Let's go train data custom.classes. Is that equal to train, oh, I don't want 3 equals, train data, the original one dot classes, and also print, let's do test data custom dot classes. Is this equal to test data, the original one classes? True and true. Now you could try this out. In fact, it's a little exercise to try it out to compare the others, but congratulations to us. We have replicated the main functionality of the image folder dataset class. And so the takeaways from this is that whatever data you have, PyTorch gives you a base dataset class to inherit from, and then you can write a function or a class that somehow interacts with whatever data you're working with. So in our case, we load in an image, and then you, as long as you override the len method and the getItem method and return some sort of values, well, you can create your own dataset loading function. How beautiful is that? So that's going to help you work with your own custom datasets in PyTorch. So let's keep pushing forward. We've seen analytically that our custom dataset is quite similar to the original PyTorch torchvision.datasets image folder dataset. But you know what I like to do? I like to visualize things. So let's, in the next video, create a function to display some random images from our train data custom class.